We're going to be talking about coal ash, and I'll tell you a little bit about what that means. Basically, I mean, it's kind of goes without saying, doesn't it? This is the ash that is produced when you burn coal, to make a long story short. And there are really two types. There's the fly ash, which goes up the smokestacks and is removed from those by electrostatic precipitators. And there's the stuff that falls down to the bottom, and that's what, you know, when we used to burn coal in our houses, those were kind of like the clinkers that you would take out and bury in the backyard. I know that because I keep digging them up every time I plant flowers, you know, so they're out there. So the ash that we're going to be talking about today, though, is what they call bottom ash, and that's the kind, again, that falls to the bottom. It's the main ash, in other words, that is left over after you burn coal. The picture that you see here is one that actually I stole from a book or something, but I really like it because it has this nice little village here, which kind of looks like Western New York, and behind it is this incredible power plant in the background. I'm not here, by the way, to disparage the coal industry or the people that run the power plants or any of that. We have a wonderful power plant, coal-fired steam plant right here in Dunkirk, as you all know, and these are fine people. They're working to provide electricity for us, including the electricity that's being used right now in this room. So we should keep that in mind. So anyway, let's go to the next slide here. And this is the outline of what I'm going to be talking about. We're going to look at coal first. You kind of have to do that if you want to understand ash, because obviously the constituents of ash have something to do with the coal. It's what's left over again after you burn it, and you propel a lot of the materials that were originally in the coal up a smokestack. So we're going to talk about what is coal, what is the composition of coal, and within this what is coal, it's a little bit, I'll tell you a little bit about it, how it's formed, the environmental effects of coal burning, which many of you in the room probably have some inkling of already. And then we'll look at the ash. And I have this kind of mysterious thing here. Is it actually cleaner than coal? And we'll look at that. In other words, could we just as well just put coal all over the roads, you know, to melt snow and things like that? Or is the ash something that's better because it's cleaner? Ash as a potential environmental, or the potential environmental impact of the ash, and we'll take a look at that. And that will be the climax of this at the end. Okay, what is coal? A lot of people, I would imagine, take for granted what coal is. As it says there, it's combustible. Must have been very surprising to people back in ancient times when they put blocks of coal around a campfire and it started to burn just like the wood. It's a sedimentary rock, meaning that it's formed, it's like particles from other rocks. It's not molten, it's not a metamorphic rock that's formed by heat and pressure and that sort of thing. These are rocks that are formed up close to the surface. And by the way, diamonds do not come from coal beds. I want to tell you that right now. That's something I have to teach my students. It's a black sedimentary rock usually, and it's composed, guess what, of mostly carbon. And the carbon is what is doing most of the burning. Combines with oxygen, makes carbon dioxide, and it also makes heat, carbon monoxide too. This is stuff that was formed in swamps. It is swampy material. It's just plant life, and you have to have a lot of plant life. So it's mostly what we would call jungle material, right? It falls down into the floodplains of think about the Amazon River going, you know, through a jungle in Brazil or whatever. Those are good places to make coal. Mostly they're formed in deltas. If you think of something like New Orleans to the south where the Mississippi River Delta is, coal is being formed there right now. One thing about deltas that is good is that usually they are swampy areas. They have a lot of vegetation, and the other thing is they're right next to the sea, and they're usually in a big depositional basin, we call them, and those basins are filling up with sediment and they're dropping. They are sinking. And so the coal, when it's being made, it also is sinking. And to make coal, you have to do that because you have to have heat to make coal. You have to transform, in other words, this vegetative matter into some kind of a rock. You have to have heat to make that transformation. And we'll kind of show you an illustration of that in a minute. So they were formed mostly in what we call, or actually what the people in the UK call the Carboniferous, which is a very adequate word for it. It's the time when most coal deposits were formed. As it says, they're 286 to 360 million years ago. The rocks around here, by the way, in Chautauqua County, are the Devonian period rocks, and the coal was mostly made right after that. Our rocks are about 370 million years old or so. We have, in the United States, about 200 years of recoverable coal, which if you're a coal fan, that's a good thing, and if you're not, that's a bad thing, obviously. But it accounts for nearly, as it says, there about 50% of the electricity that flows through the electrical grid, and the rest, of course, is renewables and other things. These are some pictures of coal. I don't know if you can see this real well. This projector is a little too close to the screen. But there are about 4 different major types. The one is just peat, which you can, which really isn't coal, but that's what coal starts out being. That's something that you can just go down to your agricultural supply store and buy, right? But then that turns into lignite with some heating, with some metamorphic action. And lignite is soft coal, or what they call brown coal, and you can actually burn it. It doesn't have a lot of BTUs in it, a lot of thermal energy, in other words, for volume, but it can be used. It still is used in some cultures. The bituminous coal is the next one, which is this. That picture, by the way, is an actual picture of coal from our Dunkirk power plant. And because they have kindly provided it to us so that we can show it to students and that sort of thing. But this is a piece of bituminous. This is a coal that is mostly burned in power plants, and this is what would mostly be producing the ash that we're going to be talking about today. It's a fairly high grade of coal, a lot of carbon, has a lot of thermal energy per volume, which is what you want. This one over here is anthracite, which is the prettiest type of coal that you will ever find, and it's also the highest in heat content and the most valuable, and also the most rare. It was mostly mined around here in Pennsylvania. It's still used in some places to heat homes, but they don't use it much in power plants because bituminous is a lot more cost effective. Okay, by the way, anthracite coal is sometimes molded into wonderful little figurines like coal miner figures and things like that that you can put on your mantle. You can't do that with the other ones. Coal has lots of uses, in other words. The composition of coal, what is it made out of? It's mostly organic compounds. And if you can see this thing, that's a very complex organic compound, lots of chains of carbon and oxygen molecules here, which are these round things that you see here. It also has nitrogen, and it has phosphorus, and it has a lot of other things that are forming some of the bonds in here between the carbon and the oxygen. The more carbon that you have in coal, the better. Anthracite usually has more carbon than the others, etc. Bituminous is also very rich in carbon. And the more carbon you have, the higher the heat content, etc. But there are other things in coal besides just carbon and oxygen. As you can see here, there's a whole list. And one of the worst things that is in there as far as the environment is concerned are these things called sulfides. You've probably heard of pyrite, which is an iron sulfide that we call fool's gold. Pyrite is actually a mineral that you can find in usually trace amounts in coal. And the problem with sulfides is that not only do they have iron attached to them, usually they have a bunch of other heavy metals that like to go with iron in the sulfur. And here's a partial list of them here. Hg is mercury, this is cadmium, selenium, arsenic, lead, nickel, vanadium, beryllium, barium, chromium, copper, molybdenum, zinc, uranium, and thorium. And radium, which actually probably mostly comes from the decay of the uranium and thorium. A lot of people don't realize that's in coal. But you're standing here on the shore of Lake Erie right above the Dunkirk shale, which is black and also has those things. In fact, the Dunkirk shale is very much like coal, and that's why it looks black.